You know, it
Bulk
takes
moisture.
exactly bulk moisture. It's also insulation. At the same time, you know, it's airtight. So, but if it's hot, it really expands fast. Now, another aspect of passive house, because you build your envelope so tight, you need to ventilate. And what we use is this is called the Ultimate Air Recuperator. It's made by a company in Ohio, and what it does is it's an energy recovery ventilator. But what it does is constantly there is air, stale air is being exhausted from the kitchen and the bathrooms. So if you look at this is actually the one that's going to take out the stale air from here. And then at the same time, fresh air is coming in and being supplied to all the bedrooms and living space. Why is it called energy recovery ventilator? It's because as the stale air that goes out, you know, if you don't recover some of that heat, you have to reheat the fresh air that's coming in. So what it is it's actually transferring that heat as the two streams of air intersect, and it's the recovery rate is up to 95%. So this is a very efficient.
If you go back one, I want to tell them something. So
Sure.
the Panasonic that you saw in the basement of the last house had a honeycomb configuration. This one is using a desiccant wheel.
Yep.
That's what this is. So it'll spin around, and when it gets to the incoming air, it will release the heat and the moisture in the wintertime. And when it gets to the outgoing air, it'll start to pick that up. So,
Exactly.
so it's just like the honeycomb version you saw, but it has a desiccant wheel instead.
Yep.
And the reason I put this out, those of you who worked in commercial, and I know you're in here somewhere, you usually see huge desiccant wheels, right? And
Yep.
so this is just a smaller version.
Yeah, they can build this. I mean, I've seen one. They custom made for a passive house in Charlottesville. It's actually the Waldorf School. It's 5 times the size.
Yeah.
Yeah. So.
Where at Ohio? Is that based?
Athens, I think.
Athens.
Yeah, yeah. It's Ultimate Air. That's the company. And also, you can email me. I'll let you know. Give you the contact. The engineer that designed the system, he actually built a passive house himself.
Because they use those a lot in basement as well.
That's right.
Part of the selling of their waterproofing, they use those in basements, and Ultimate Air has a package that they throw in with the.
Okay. Okay. Now, also another aspect is we seal all the ducts with mastic, and if you see it's all there and above. Everything we try to be as centrally located, as short and fat as possible, so eliminate inefficiencies. Now, all the duct work is actually only for the ERV. We don't have a what we are doing, with passive house, what you do is you take, in terms of HVAC, you take care of ventilation first. Once you take care of ventilation, because the heating and cooling loads are so small, in this house, this is what we're doing. We'll put in a mini split system right there. And this is a 1.5-ton reversible heat pump, Mitsubishi Mini, Mr. Slim, I think it's called. Usually used for 500 square foot of space. Our house is about 3,500, and it is enough to cover that. So.
What are these part of that?
That's a good question.
Yeah.
But these are transfer fans.
Okay, to
You
allow
see
the
them?
air to go upstairs.
Yeah, you see them in every single room. The reason we put this is because sometimes nighttime when you close your bedroom doors, there could be temperature stratification. There could be a difference of maybe 10 degrees or so. So this is an insurance policy. What we're doing is, as the air blows out, conditioned air blows out from that mini split, this will suck it directly into the rooms, and it'll supply it so that and also it'll ventilate the entire house this way.
So what's the size of the mini split?
Mini split is 1.5 pounds.
And that's the highest it goes.
No, they can go up to.
No, but yours is 1.5.
Yes.
Because 3,500 square feet, 1.5 tons.
Yes.
Unheard of, right? Unheard of. So.
Yeah. So I mean, I think normally it would have to be 4 or 5 times bigger. You know, if you go the traditional route, and so that tells you, you know, how much heating we're all wasting. You know, I live in a builder grade house right now, and just every time I come here, just want to move in because it's just crazy. My heater is always running. So now, so this is the specs of the house. Thermal envelope, really good windows. These numbers have been revised. We ended up using something a little bit different, but like I said, the U value is about 0.1. Solar heat gain is about 0.5. Really tight construction. Passive house requires 0.6 air changes per hour at 50 pascals. It's you know, it's a pretty hard number to hit, but it is doable if you build it right. And this is also a qualitative measure, because if you can build a house so airtight, that means the craftsmanship is good too. So we have really thick insulation, R40 walls, R60 roof. In terms of heating and cooling, we're using ERV, 95% recovery. We have a very small heating and cooling equipment, 1.5 ton, and really small utility bills.
Are these standard for passive? You guys?
Yeah, I mean this will be considered sort of a standard passive house. I mean, some people go to extremes, you know, depending on the climate that you're in. For example, we have a friend in Fairbanks, Alaska, and that is extremely cold. He's built a house with 24-inch cellulose walls, you know. But over here, we don't need to do that quite as much. So, and you know, places in California, say San Diego, you just need to build slightly better than you know, code, and you have a passive house. Just need to make sure it's airtight. What does it all mean to the person who lives here? Extremely high indoor air quality. Not only does this ERV constantly supply fresh air, it also has filters. It's a really good filter, MERV 12. MERV 10 is for hospital labs, so this is even better than that. So there will be no draft because it's airtight, so you know, if you go to the windows, you won't feel drafts. No temperature stratification, and all that together, you just feel comfortable. And the heating needs are so small that after our calculations, you can actually heat the entire house with 2 blow dryers.
But we wouldn't do that, because that would be energy inefficient. That's
Exactly. But that's the consumption. That's how much these 2 will draw the same amount of energy it takes to heat the entire house. So. And so these are our calculations ended up being for our electric bills. Heating and cooling is going to be you know, 6,829 kilowatt hour, and it's going to cost about $567 a year. This is calculated based on the, you know, 8.3 cents per kilowatt hour. That's only $47 a month, you know. And if you count all the other loads, your plug loads and whatever other usage you have, it's about 16,000. This is our estimate. It's only $111 per month.
So a couple things to say to that. The last house we were at had about the same heating and cooling costs, but it wasn't quite as large, and it was a row home. So it had an insulated home on either side. This is a standalone home, so that's a big difference. The other thing to think about, are energy prices continuing to go up, or are they going down? They're always going up, so the longer you live here, the better it is.
Exactly. So, I mean, the way we're consuming is really just not sustainable.
Yes, right. It could be difference between DC pricing and Virginia pricing.
So, I mean, also, the other thing is, you can even get this number lower if you use natural gas. But we chose not to because it's a tight house. I don't really want any kind of combustion gas in here. So, that's another consideration. So, one more thing, with this passive house really is the easiest way for you to get to net zero because you minimize that heating and cooling loads. So what you can do is you can go put on photovoltaics, but then if if you're only paying $100 a month for electricity, do you want to spend, you know, tens of thousands to put that on? You know, that's another consideration, because there is a lot of, you know, photovoltaics is great, but the manufacturing of photovoltaics is not necessarily green, and, you know, transport and everything like that. So, but it is something that to think about, because you're so close to it, you know, if you have a passive house. And what else? Well, beyond passive house, these are the other things that we're doing to this house, you know, that are, I guess you could consider them green. We use precast concrete walls and SIP panels to minimize on-site construction waste.
We'll show you those when we go downstairs.
Mm-hmm.
We'll talk about
I'll show
that.
you those. We have a green roof above the garage that will catch some of that storm water. We're using low VOC wood flooring and cabinet. We're actually going to put bamboo flooring in here. No VOC interior paint and primers and things like that. There is fly ash in the concrete to increase the strength and reduce cement content. They also added fiber mesh in the concrete to reduce rebar use. It also reduces cracking. So we're lighting the entire house with CFLs and LEDs. Prices have really come down on the LEDs, so there's no reason not to do it now. We're going to wire the garage for electric cars. It's actually really easy. You just need a 220 in there. And then the roof is solar ready because we're facing the south. And just need to put a few wires up, then we're good. Low flow plumbing, that's a must. We probably should do more next time. Maybe we'll start thinking about gray water, but then you run into some code issues, so you need to convince those guys in the county. The garage house separation that I told you guys about, you know, it's really for cleaner indoor air and no penetration into the thermal envelope. We're using permeable pavers and rain barrels to reduce stormwater runoff. And that's pretty basic, you know. So.
Is there a cost per square foot?
Cost per square foot, we're trying to limit it to about somewhere around 150, 160. So.
High, but it's coming down, and again, they picked some pretty advanced technologies to use and techniques, so you can.
And we're definitely learning, you know, climbing the learning curve right now. You know, and this is the thing, you know, I think, why would we do this? Because, I mean, you know, if you can do this, there's no other builder who can in your area.
Is that price including your factoring your savings from the, you know, your
HVAC.
Yeah,
Yes.
and so forth.
Yes.
So,
I mean, if you think about the concept, it's very simple. You're adding insulation, you're reducing your HVAC system. You know, a typical HVAC system for houses size will probably cost, I would say, maybe 30,000 in this area, 40,000. Ours is going to cost 10,000. You know, and how much insulation can you buy with 20K? A lot of foam. So. This is our contact information. You can also follow us at arlingtonpassivehouse.wordpress.com. We keep a pretty active blog. So there's videos and pictures. So.
And you have it in your pamphlet.
Oh, good.
Okay,
Yeah.
great.
So now, you know, if you guys like to walk around the house, you can do that.